All right. Thank you for your patience. It has been awesome. It has been crazy. It has been busy. Let's get on to project number 2. Project number 2 is called Rougher Waters. We're going to learn how to read temperature and humidity. All right. So, what we're going to need is we're going to need our handy dandy Arduino knockoff Elgu Uno R3. We're going to need some sort of jumper cables. Maybe yours have this at the end. Maybe you need the little jumper spikes to stick in wherever it may be. We'll get that. And our DHT22, right? And then we'll want our, what is it, USB-B, I believe it is. And this one might look different than yours, but it's still the same thing. All right. So let's flip you around. Let's come down here. Let's start plugging stuff in, all right? So first things first, we could pick any pin out that we want. For our purposes, we're just going to use pin 2, okay? So we're going to take this, and first things first, remember that we have, so important to know about the DHT22, and you can read about this also, but it has certain tolerances, and it has, tolerances mean a certain amount of error, or like how accurate it can be. For the DHT22, it also can only sample once every 2 seconds. That means that in our code, we do not want the sampling rate to be faster. Okay? There, you can see that. All right, so the left pin is plus, the middle is out, the right pin is minus. Plus, we always want red if possible, but sometimes we get funky colored cables like this. So we're just gonna plug it in, all right? We're gonna remember which color is which. Like that. And I put my finger to support it. All right, cool. Cool. Nice and plugged in. All right, so orange is plus, yellow is data, which actually that's normal convention. Green is minus, which we're gonna take as ground, right? So plus can go into the 5-volt spot. So I want you to look on yours, okay? So 5-volt is next to the 2 grounds. We're gonna go, the plus side goes into 5-volt. Minus side goes into ground. It can go into either ground. I like to leave an empty spot if possible. And then data, we're just choosing pin 2 because that's convenient for data, okay? Bam, done. Now we can hook it up. Cool. All right. We're good to go, and it did a little blink to say that it's chatting with the computer. Now, today we're going to learn something new, okay? I'm going to have to turn you around and tilt you a little bit. Okay, we're going to learn something new. We are going to learn how to install libraries, all right? Install and manage libraries. So if you have not done this before, I want you to take a good look at this. Open up the Arduino software, all right? And create a new file, and we're going to go into Tools, okay? I don't know if you can hear Red over there. Hey, buddy. He's chatting with me, too. Good boy. This is Red. Good boy. All right. So we're going to come up here. Hey, bud. I'm recording for the Reynolds. All right, we're going to go up to Manage Libraries. Now, there are 2 libraries that we are looking for right now. You can see them in the instructions right here. So when we go to Manage Libraries, this thing pops up. All right. So it's downloading the libraries index right now. That's fine. Don't worry about that. That's because I have to switch back and forth between Windows and Linux. Cool. All right. Updating. There we go. So we're going to go Adafruit Unified Sensor Library, okay? And when it pops up, it might take a second. Remember, this computer I'm working with, it's very old. If it doesn't pop up right away, we might have to scroll through it, and you can see it's alphabetically ordered. So we can jump down here. There we go, that one right there. And I could click on Update. You should see Install. So click Install, let it install, do its own thing, okay? And then the second library that we're going to need is DHT Sensor Library, all right? right there, that one. And we will we'll install that one too. All right, cool. Now that we are done with that, let's get on to some coding. All right. So everything's hooked up, plugged up. What we need to do now is include those libraries. All right. So hashtag include Adafruit. Cool. This is so we can get all the functionality that we need to read this. Cool. All right. Nice. Now let's save our file. All right. I already made version 1 of this, so I'm making my own version 2, but you can give it your name, testing temp, and humidity. Okay, just for consistency. Save it. We're good to go. As we go, make sure to hit Control Save, Control S, or come up here and click Save, so that if your computer crashes, runs out of battery, anything happens, you can go back and get your file. Okay. All right. Now, right now, what we're going to do is we're going to define our DHT pin, the pin we plugged it into. Now, we could call this whatever we want. I'm just going to call it DHT pin 2 because when we name things, it's best to be descriptive. Okay. Now, the reason I put the 2 at the end is to indicate that we're using pin 2. I could have just named this DHT pin and it would still work, okay? But the reason I use 2 is because we could use pins 2 through 10 and we would need to describe, like, differentiate between each of them. If you really wanted to, you could even drop all this and just do D2, okay? But I like DHT pin 2 so that we remember what it is. And then we're gonna come here and we're gonna define the type of sensor we're using. DHT type DHT22. The reason that this is that there are a bunch of different DHT sensor types, all right? Now, if you look in the code file, you'll see a bunch of comments. And the thing is that we like commenting things to communicate with other people or to remind people of what's what. All right, so I'm gonna have to cheat and go back because I spent some time thinking about my comments as I went, and right now I'm woke up and I'm not thinking about that. So we could, you know, a couple different ways that we could comment. Okay, we could add a space. We could try to align them all. Oops. Okay, we try to align them all. Some people even do comments before or after the line. We're gonna just have it with a space at the end of it because it's the others are too challenging and too messy. All right, we're gonna go digital pin connected to the DHT sensor. All right. Which is also known as an AM2302. Cool. All right, nice. Can save. Control S. Now let's actually create an instance of our DHT or a DHT object, the sensor object. So DHT unified DHT2. We're gonna name it DHT2 again. The name we could pick whatever we want. We could call it Bob. We could call it Sally, but making it a descriptive name is gonna help us. And then we're gonna use these variables, DHT, these defined variables, pin2 and DHT type. If you really wanted to, you could just plug 2 and DHT22 in here, but that's not a very flexible or versatile way to do it. All right, let's save. Let's come down here. Now we're just gonna practice using different data types. In this case, it's so that we can be specific. This could have been just an int. We could have done just int delay ms. But we're creating an unsigned integer that's 32 bits long. I can't remember what this T is. And we're going to call it delay ms. That's going to be our timer delay, all right? Now, let us get to creating the setup, okay? So all right, void setup. Now, Here's the cool thing. Since we are using the serial input output right here, all right, that's this. USB stands for Universal Serial Bus. And when we're using that, we need to tell the Arduino software and we need to tell the Arduino itself, hey, it's time to start doing this thing, okay? So we're gonna go serial begin 9600. 9600 is, what goes in here is what's called the baud rate, B-A-U-D. Baud rate just has to do with how fast the data is being sampled. 9600 or transmitted. 9600 is a very common baud rate for us to use. There are a bunch of different ones to use. If you want to see them, we can go Tools, Serial Monitor. I'm going to come down here. You can see in this corner that 9600 actually ends up being the lowest. Now you shouldn't see this stuff show up. This is because I already have code on the Arduino. 9600, oh, it's not the lowest, I'm sorry. But it's, yeah. So we could pick different rates if we wanted to. We're going to do 9600 because that's the common one. All right. There might be a better reasoning behind it, but that's good enough for us. Now that we have started our serial connection, we also need to begin the sensor, right? Begin the DHT, tell the DHT2 to begin. This is its own function in the DHT2 libraries that we don't have to worry about where it is, we just know we need to use that. We're also going to create a sensor instance, okay? Again, you can see the comments on the left if you really want to. I'd recommend adding them. I'm not going to add them here just to keep the video short, okay? And we're gonna actually give a value to our delay. Delay ms equals 2000. 2000 again in milliseconds. That's 2 seconds. That is the lowest we want to create this, okay? For the Blink project, we did it shorter, we did it longer, you played around with it. In this case, do not make the value less than 2000. You'll just get errors, it gets confusing. It's not really interesting what happens. You could, if you really wanted to, you could try. You know, the program might fail, the Arduino might stop working. We actually accidentally created a faster sampling rate for one of our data collection things, and all of a sudden everything was breaking and we didn't know why. We had to go back to documentation and figure out, and we came to the conclusion that our sampling rate was too fast. Slowed down the sampling rate, so we made this number larger, and we were very, very happy, and everything works and it's perfectly fine. Cool. All right, everything's set up. The serial's begun. We've created an instance of the DHT sensor and the sensor object itself. Now let's go create our loop. Now, super important, okay? When we loop, we want it to go as fast as possible, all right? As fast as possible. In order for the loop to move as fast as possible, we want as little as possible in there, okay? It's like if you're running and you have a backpack on. The less you have in your backpack, the faster you can go. So we want this to have as little as possible in it. And also what those things in it matter as well, all right, and how they work. So we're just gonna practice that now, but in future projects, we're actually going to apply it, all right? So we're gonna have our delay. And we put this at the beginning so that when the Arduino starts running the program, it gives a 2-second pause for that first sampling. So if you plug everything in and start it up, you don't get bad data, you don't get a crash. It pauses for a second and then is able to get a good sample, okay? There's an even better way to do this, but we'll figure that out in a future project. And what we're gonna do now is we're gonna create a function, okay? Read sensor hand print. It's gonna take the DHT2, and it's gonna take the DHT pin as well, okay? And you'll see why. This way we only have 2 things in the loop, all right? Again, in the future, we're actually gonna do this properly. We're just practicing it right now. Cool. Down here, now we're gonna create our own function. we're going to make it a Boolean, which comes out as true and false. Again, this is just using a different data output type, and this is to practice so that in the future we can apply it. So we create another sensor object. We're going to call it cur, and that's going to take DHT2 through it. Okay. This is just a placeholder, but it tells the function what data type it's going to take. All right, which is why we can plug this sensor in there. Then we're going to go and take the pin number as well. Okay. Open our function up. Let it close it. Cool. All right. Let us define some variables. Oh, hey, I'm missing one there. Uh-oh. That's right. I'm sorry, this is the more advanced one that we're looking at on the left. Pretend like you don't see that. Let's go to the... All right, cool. All right. So double. What is a double? Double is a data type, and it can take decimal point precision. All right, we're gonna go temp double humid, just to keep them short. Okay, that's so we can work with the sensor event. All right. Again, this is a piece of wizardry that we're gonna plug in. We don't have to worry about what it means. We just need it there. Okay. And we're gonna get that temperature event. In C++, the and putting that and there means it's a pointer. This gets into some complicated stuff that I wouldn't even do a good job describing. It's been maybe 15 years since I took C++, and I've played with it on my own since then, but on and off. It's important to get comfortable with using things that we don't have to be masters of, okay? And just being able to work with them. If you want to be an expert in C++, it's good to go and learn about it, but we're not going to worry about it too much, all right? Because we're not trying to be experts in C++, we're trying to build a cool Arduino project. All right, now, we want to check for errors, okay? So, now, the reason that I'm putting the comments above the function and above this thing here is because they're long lines, and I really don't like, personally, I don't like putting comments after a bracket. The bracket, imagine, is an opening for all of this stuff down here. And ideally, we'd want to put this stuff right in line with it, but that would make this line spill over and be super long, and that's just nasty. So before either really long lines, or before like a function or a conditional statement, we'll definitely do our comments. Okay, so we're gonna go here, check for error in humidity. If no error, then set humid to the sensor events. Boop. Relative humidity output. Cool. All right. So if is not, that means is not a number. All right. We should be getting numbers out of this, but if the next thing is not a number, and the next thing is event dot relative humidity. Okay. If it is not a number, then humid equals 404. The humidity should never be 404. It is going to be between 0% and 100%. So 404 tells us that it's a bad value. All right. It means that something's broken, basically. But if it is a number, then we can go humid equals event dot relative humidity. Now, can you imagine that sometimes we'll get a number out that's bad, and we still go to this part of the conditional statement? If you said yes, you're absolutely right. We could, if we wanted to, put another line in here that said if or else if humidity is less than 0 or greater than 100, spit out some error. We're not going to worry about that, okay? For our cases, we're just going to assume that things are going to be good. And if the number that gets printed out in the future is bad, then sorry about that. Then we can go back and add that conditional statement in there. But again, we're just trying to get straight to this project. So, all right, cool. Now, not just with the humidity though. I apologize. I missed a part of the code. So let's go back up. Let's go back up. So you see that I did this for temperature, and then I skipped down to humidity. I'm going to have to fix that. So I accidentally skipped ahead. Here we go. We can go back. So since all right, Red's outside now. Ugh. He's a good boy, but sometimes he doesn't know that he shouldn't be crowing. All right, so we gotta go back up here. I accidentally skipped that whole temperature section you see on the left. And what we're gonna do is basically the same thing. So we got the temperature, you know. All right, fix that. So check for error. In fact, what we could do is we could just copy this. If you hold shift and press the down arrow and then back, it'll get that whole line, okay? Cool. Now we're gonna change this to temperature. Cool. And this is gonna just be temperature, all right? Now, super important. Oops, that was inconsistent. Super important. People have different preferences about spacing and brackets and whatnot, okay? Figure out what's the best convention and then do your best to be consistent with it, okay? With functions, sometimes we'll add spaces so it's easier to read. And then with conditionals, we just package it all together, okay? And here we're gonna go, so if it's not a number, again, then we want temp to equal 404. Else temp equals events. Sure. Cool. All right. Now, you see that this line's here, right? We need the same thing for humidity down here. This was part of the mistake that I made, so we're gonna go back and fix it. All right, so this is getting temperature events. And this right here is gonna be cur dot. Okay. All right, cool. So, what is going on here? Let's briefly talk about that, and then we're gonna get to output formatting. Oh man, what happened with the? It's ugly. That's better. All right, the indenting. We like indenting to be consistent. This is especially important in languages like Python, where indenting is everything. Indenting tells you what's part of what. You don't do the brackets the same thing. It's really messy, especially if you start using a language like C++. All right, now that, so what's going on here is we take that DHT sensor object that we defined in the function, okay, right here. We passed DHT to the sensor that is currently being read, because see, we began that sensor up here. Okay, we defined it up here, and then we began it in the setup phase. We passed that sensor that we're working with into the function, but now we call it cur for current. So it's the current sensor. If we wanted to, we could also reuse this function for a DHT3, a DHT4, a DHT5. In our facility's sensor system, we actually have up to 10 sensors per. So this makes it super useful because you can create something called a for loop, and you say for sensor 1 through 10, do this. And it's a pretty compact way to just run through the whole thing. And each one, current gets redefined to DHT1, then it gets redefined to DHT2, to 3, to 4, to 5, etc. All right, now, when we take this, right down here, we come down here, we see cur.temperature. Well, guess what? That actually is DHT2.temperature, because that's what we're plugging into the function right here. And so we're taking this temperature function and we're getting its event from the DHT22 sensor, okay? And what we do is we check that event temperature right here, and we ask, you know, if it's not a number, we tell the program to set it to this value so we know that there's an error. Otherwise, we set our temperature variable that we defined right here to that event temperature. Same thing goes for the humidity down here. Now, the last thing that we need to do is we need to format the output. Okay? Now, if you have worked with C++ before, you know that I'm making a terrible mistake here. And that is that oftentimes you want to set and get things in different functions. You want to set variables and then get variables using different functions. And then ideally you print the output in its own function. But we're just going to slam it all together here because this isn't a class in C++. This is a class in Arduino programming. And you'll find that people are a little bit more loose about that. So we are using the serial input and output, and this is where we really tap into that. Okay? I wonder, I have no clue how outputting's spelled. I am a scientist and an engineer. I'm not an English major. I apologize if I spell it differently two different places. So we're going to tell the monitor to print. Now, this is special. F stands for flash. We use the flash memory in order to save some running memory. So it basically says, okay, this is always going to be this. Let's just keep it that way and save ourselves some trouble. All right. Now remember how we passed the pin value back here? We passed DHT pin 2 through this into the function. We're going to come here and now we're actually going to use it. All right, pin. Whoop. Cool. Again, we're going to use the flash. This is for formatting purposes, and you'll see in a bit. And please do catch me if I make a mistake. Again, you can use the text tutorial. You can open up the code and look at it. I've found that, you know, oftentimes I can look at code, I can take it apart, I can rewrite it like I'm doing right here, and that will help me. Whereas sometimes reading is a little bit harder for me to pick up and learn something with. Do whatever works best for you, okay? I'm going to try to keep these projects short, but as they get more complex, it's going to get a little bit longer. I also tend to be verbose. Now, that last part, return true, here's what that's about. Back up here, the function said bool, right? Bool, boolean. That means true, false, or 1 or 0, okay? When we have this data type in front of a function, so void means nothing. It means there's no return value, okay? That function does not return anything. In this case, this means that this function is going to return either a true or false, and we can use that again in the future for things. So basically this function actually isn't just a function call. I mean, it is a function call, but it also returns a value. We just aren't using that value. So at the end of the function, we're just going to say return true. In the future, when we want to use that value, we might have an error condition here, and we might have it return false. And what it does is it'll break that function, jump out, and return false. Okay? Cool. Now that we're done, what we can do is we can save, Control S, or go up to File, Save. We're going to verify the sketch, make sure we didn't make any mistakes. Now, here is something really important, okay? Really, really important. Oh. Hoo-hoo-hoo. What did I... Sensors event. Sensors event. Okay. Fix that. Cool. Now, verify might work because your code might all be right. There might be nothing wrong in your code, but your program might not run right, or it might break, or it might not run the Arduino at all. And that has to do with the fact that the verify is just checking to see if everything's right. Like, I missed an S here, and I could see down here, if you looked at the error text, you go back and look at that. Okay? Maybe you miss a semicolon. Maybe you miss a bracket somewhere. It'll tell you where there's an issue. When it comes to brackets or parentheses or quotation marks, it gets really messy because it gets confused. Okay? And then we have to really dig. All right, so let's go up here. Let's make sure our Arduino is connected. And if it is, we're going to click on Upload. See compiling, and look at that. All right, so last time I did this, I got an error value, but then my video crashed and I wasn't able to upload it for you. This time, no error value. The reason it crashed last time is because the USB wasn't being recognized even though it was plugged in. So it said it was plugged in. I had to plug it into a different port, get it reassigned, and figure that out. It's not always obvious. Try plugging into a couple different USB ports. Try slowly working through and seeing if you recognize any words or language in the error stuff down here. You can scroll back and forth or up and down. You can even resize this. See that? It'll typically either tell you the answer about what's wrong or give you a hint. In this case, it uploaded. Fantastic. What we can do now is we go Tools, Serial Monitor. Whoop. Serial Monitor is going to get going, and there you go. Pin 2, that's our pin that's connected. That's our temperature in Celsius, though, not in freedom values. And here's the relative humidity. Awesome, cool. If you just wanted the simple version, that's it. You're done. Go home. Have a wonderful day. It's great to know you. But, as always, there's more. So, let's come down here and, yeah, congratulations. If everything worked, you've created a temperature and humidity reading sensor. You're done. That's it. There's more. All right, so let's talk some. So, as you go into science classes and whatnot, you'll learn that there are different temperature scales, but they don't always tell you why. I'm going to explain why right now. Some of why. So the Fahrenheit scale. Fahrenheit scale is really well suited to high resolution. Okay. There are more values between freezing and boiling. All right. There's what, 180 values? Yeah, I think there's like 180 individual integers, right? 33, 34, blah, 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 210, 211, 212. Okay. 180 values. But then you go to the Celsius scale, there's only 100 values. So you don't quite have the same precision, all right? The Fahrenheit scale is actually ideally suited to the human body, if I remember correctly. It's really useful when we talk about humans. But now we go to the Celsius scale. The Celsius scale is actually really great when we're talking about water. And then when we're talking about a lot of other of the system international units, the metric system. Okay, but there are other scales too. There's the Kelvin scale and the Rankine scale. Kelvin is to Celsius what Rankine is to Fahrenheit. Okay, more or less. It's not exactly that. It's not precisely that, is it? but it's close enough. So absolute scales mean that they start at absolute 0 and then they go up. You'll see that, look at this. There are 491 values here, all right? And there are almost the same amount here for, oh no, it is. You had 32, right? So add 32, no, sorry, add 66 here, all right? And if you add 66 here, you'll see you get pretty much the same value. So that means that you're basically adding 459 to the Fahrenheit scale to get the ranking scale. 459, right? In this case, you're adding negative 237, or you're adding 237, okay? Kelvin's great because it starts at 0, same thing with ranking, but you'll almost never hear about this one. There are a whole bunch of other temperature scales, but we're not going to go into that. That's way too much. Check out the Wikipedia link. It'll discuss them. These three really are the ones that we care about. In everyday stuff in the US, this is what we care about. This is a really powerful one to learn. So the sensor automatically uses the Celsius system, but we want to use freedom units, as some people call them. But yeah, so that this video doesn't go too long, what I'm going to do is we're just going to plug in the code. We're going to format it. What we want to do is we want to use Celsius. We also want to add a % sign, degrees, whatnot. I highly, highly, highly recommend going in and copy and pasting from the code. It'll be a lot faster. So we're going to come over here, and if you're doing the advanced part, I think that you absolutely can handle this. You see me jumping around all this different stuff. Create an advanced file. Okay, here's our advanced file. I'm going to show you it in its full glory. What we're going to do in the advanced file now is we're going to come up here. We're going to add temperature Fahrenheit, but we're going to use float. Okay, floating point precision. Float allows us to get decimal points. Again, this is just a different data type. We're going to come down here and we're going to create a new function. Okay, now remember how I said that we can use, I'm sorry about that. Go back. Come on. Really nice if my phone zoomed in. Zoom, please. Haha, being nice works. All right, so we do float temp F. We come down here. See this? This is going to be our converter function you see right here. Now remember how I said that this data type output for a function, okay, it returns something, right? We return a value and then we use it. We're going to use that now, all right? So let's plug that temp value that we got from our event temperature into this converter function that we create. And we're going to create a new variable. We created it up there. We're going to assign the temp F variable to whatever the output of this converter function is, all right? And then we're going to come down here, and here's the cool thing. Check it out. In the converter function, we're going to take our degrees Celsius. That's our temp that we got right here. We got right here. And we got from this event temperature up here, okay? We plug that in. Okay, we're going to create a new deg F variable, set it to 0. But then degrees F is going to be this calculation right here. It's going to take degrees C, and it's going to run it through a conversion. We return that value of degrees Fahrenheit, and that gets returned through this float value, okay? We return that degrees F, and that comes back all the way up here to that. And now we're going to take that degrees F, and we're going to swap it out for what was there previously. Bam! All right? And now, instead of what we had before, we're going to add this degree sign. Now, this is super cool, and I don't always remember the value, so I'm going to have to come back here, and I should have put a comment there, okay? Should have put a comment. It's an alt text value. Well, let's do a Google search for that then. All right, so alt value for degree sign. Check this out. Alt 0176. 0176. So I want to show you something cool. If you never learned about alt values, this was the coolest thing to learn. If you hold alt and then do 0176, bam! When you let go of it, you get the degree sign. Alt 0176. Now, if you want to, you can play around, press Alt 0, I don't know, 2555, and it gives you a different symbol. All right. That works on Windows, by the way. Or you can do a Google search, copy and paste the degree sign here. Degrees Fahrenheit, we put a percent here. And now we're gonna upload it. Oh, I hope the right, there we go. We go to the serial monitor, bring it up here. Let's check our output. Look at that. Now this is in degrees Fahrenheit instead of Celsius. We get percent relative humidity. There we go, we're done. You can go back, go slower through stuff. If you got that far and it's working, good job, awesome. I will catch you with the next project, Project 3. Ooh, that one's gonna get exciting. We might pull it back a little bit, but we're working towards more advanced things. And right now, at this point, we've been able to make the Arduino blink. We've been able to work with the serial monitor, install libraries, create functions and work with input, output, get data, real world data like temperature and humidity. All right? Have a wonderful break between projects. I will catch you in Project 3.